in any case, the wave that's traveling down and or the reflected wave, and I'll give you a model. Your basic model is a wave going this way and a wave going this way at the same speed with the same wavelength, okay? We're really seeing that here, okay? Imagine you have an infinite wave train coming from the left and an infinite wave train coming from the right. Well, aren't the subsequent cycles going to look like this? At some time, this wave's going to travel a quarter of a wavelength and something's going to change, right? And then another quarter of a wavelength and another quarter of the wavelength, and you're going to go through these cycles. But you can vary the length of the string, okay? With the same waves, if I have a string that's not this long but twice that long, then what am I going to have within that string? Well, I'm going to have 4 cycles, right? Or 4 peaks and valleys, okay?
Whatever you have will double with, or
Yeah,
it'll
so-
increase with the length of the string.
Okay, or if you wish, same string, but I'm going to have a wave with half the wavelength,
Right.
okay? So that's what one of the questions is asking about, and it asks, how do we model the function, okay? Well, I tell you that one wave, and we saw this last time, right there's a model of a wave moving to the right. Okay? This is a wave that's moving to the left. Okay? And you can understand that by the way functions transform with horizontal shifts. So you want to be sure you do understand that. Now, if I add this to this, what do I get? Well,
You get 2 a sine times 2 omega t.
nope. What you have to do is use your double angle formulas, okay? Like what's the sine of A plus B? You got a sine of omega t plus negative omega x over v, right? Okay? Well, express that as a sum of sines and cosines, or in terms of sines and cosines, using double angle formulas, and then you add this to this, what do you get? Okay, so one of the questions essentially asks you to do the arithmetic of this, well, the trigonometry. You've got to look up your double angle formula, go ahead. If you use Euler's identity, you can easily derive it. And Nelson's used to doing that because he's already had differential equations. You guys will get used to that shortly. Okay, well, Lane's seen it too. Okay, if you'd rather derive it by drawing pictures and triangles and doing that, it's much, much harder. It's actually fairly challenging, even though it's a high school geometry problem. It's not one you really expect most high school students to be able to solve. Okay? Whereas Euler's identity is trivial algebra that any ninth grader can do. Okay? One way or another, using those formulas, how do you combine this? Okay? And then the other thing is, of course, over here, there's your C, right? So by controlling the force on a string of fixed length, it doesn't significantly change length due to greater tension. You can control the frequencies that you get. So that's what the questions are addressing. That's what we're going to look at in lab. Also, how these things superpose and what the waveforms look like. It's kind of neat.